All right, so here's the 4.2 homework assignment, kind of a weird homework assignment. The goal here was to get you comfortable with the graph of exponential functions. So there's 10 problems, and the first 5 are all kind of the same in that they give you the equation of an exponential function. They ask you to graph that exponential function. And what I would like you to do, I mean, graphing functions, I have no way to know how you do these. And there's lots of different ways you can graph exponential functions. For example, you could just plug in x equals 0 and x equals 1. And once you have 2 points, you can use this graphing tool to connect the 2 points and be done with the problem. And that's totally fine. You'd get full credit for that. What maybe I'd recommend you do is rather than do it that way, think about this as a times b to the x power. So there's an implied 1. It might help to think about this function as 1 times 6 to the x power. A is equal to 1 and b is equal to 6. And based on your value of a, see if you can figure out 1 point on the graph. And based on your value of b, see if you can figure out a second point on your graph. And if you do it that way, it's a little bit more in line with the learning objectives of this section, where really we're trying to understand what a and b do to the graph of exponential functions. So I don't know, maybe that's a minor nitpicky thing, but I think it'll benefit you in the long run to think about these in that sense. And again, when you're actually graphing these, the way this works is you just have to select down here that you have an exponential curve, and then select any 2 points that are on the graph of that curve, and it'll automatically sketch the exponential function that goes through those 2 points. On this one, it only allows you to pick points that are integer values. Like if I try putting things at fractional points, it won't let me. But I think if you determine 2 points on the graph of this curve, the 2 points you would have came up with were integer values anyway, so I think that'll work out just fine. In this second one, it's more of the same. Think about this as -1 times 4 to the x power. And then my advice to you is figure out based on A, what's the y-intercept, based on B, what's one other point on this graph, and then use the graphing tool to connect those 2 points. Again, it forces you to pick integer values for those 2 points, but I think the 2 points that you'd likely come up with here would both be integer values, so that should work out okay. Third one, more of the same. We're graphing this exponential function, except now you can actually see what a is. It's not an implied 1 or -1. A is 3, b is 2. You could take those 2 points, and based on those 2 values, maybe you could find 2 points on your exponential curve. This time it allows you to pick values that are fractional, although I don't think you will pick values that are fractional. I think based on A, you can get an integer value for your y-intercept, and then based on B, you can get one more point that is on your graph that is also an integer value. Question 4. Okay, so the first thing to know here is there's the implied 1 out in front for your value of A. And now since your value of B is fractional, it's a little bit tricky. I think what they had in mind for this problem is your value of A is your y-intercept, and that will be an integer value. And then for your value of B, you could take one step to the right and find your value of B, but then you're going to have to kind of ballpark where a fractional value will end up being. And I think trying to ballpark where a fractional value will end up being could be problematic. So while you could find that fractional value over here, it might make your life easier on this one where you have this fractional value of b to take one step to the left. Because if you take one step to the left, I think what you'll find is you end up with a point that has integer coordinates again, and that'll be a little bit easier to graph, and you won't have to worry about being slightly off and getting marked incorrect with the homework. Question 5 is kind of the same idea. This is the last of these graphing ones. You can get A and you can get B. From A, you can get the y-intercept again, which should have integer coordinates. But then B, it's a little bit tricky. You're like, oh, this is fractional, so I'll just take one step to the left. But I think what you'll find is if you take one step to the left, you won't end up on these scales. You'll end up with a height that's so high it doesn't even show up over here. So you're kind of forced to take one step to the right. And when you take one step to the right, you are going to end up with a fractional value there. I guess my advice here is just try your best. See if you can get this to work with, I don't know, these aren't the right answers, but maybe there's my y-intercept. And then maybe if I decide that another point is at 1.5, just try your best to ballpark where 1.5 is. And hopefully this thing has some built-in tolerance that will mark it as correct. Again, 1.5 is not the right point. I'm just trying to demonstrate with the wrong answers. Try your best to be as precise as you can be. If it's too picky, if there's not enough tolerance built in, I'll just end up deleting the problem for everybody and marking it as correct. Then when we move over to question 6, the questions kind of change. I think from 6 on, they're a little bit harder. What you're supposed to do in 6 is they give you the graph of a bunch of different exponential functions. So 5 of them here. And just based on these graphs, you're supposed to be able to figure out what A is equal to and make some conclusions about B. So specifically what they ask you about are which one has the largest value of B, the smallest value of B, and the largest value of A. So ideally you can get all of that just based off this graph. I don't think that there's any ambiguities, at least not in the curves that they give me. I think you should be able to figure those all out, but if anything gets weird, just let me know and I'll try to help. Question 7 is more of the same. In fact, it's the exact same. They just give you different curves, but the questions are the exact same. And then we get to 8. If I remember right, 8 and 9 are kind of the same in that they give you the graph of an exponential function. So they tell you it's a times b to the x. And just by looking at this picture, maybe you can figure out what a is equal to. And then by looking at this picture, maybe you can figure out what b is equal to. And once you know a and b, you'll know the equation of this graph. Rather than ask you to type in the equation of this graph, they ask you to choose from the following list. So I don't think you need it to be multiple choice. I think you can get the answer directly from the graph, but they make it multiple choice. Fine, figure out which one works, click that box, and you should be done with this problem. Question 9 is more of the same. Look at the graph, figure out a and b, because once you have those, you have the equation of the exponential function, and you can find it in this list. And then question 10, the extra credit one, you could do this if you want. I just thought this one was a little bit harder. It's kind of like a cross between 6 and 7, where they give you all these different graphs in different colors, and 8 and 9, where they ask you for the equation of the different graphs. So here they give you all the different graphs, but they don't just say like which one has the largest value of A or the largest value of B or something. They say that these graphs correspond with these equations, and you're supposed to match them up. So maybe you can look at this and be like, all right, I know that the value of A in this green one is blank. I know that the value of A in this blue one is blank. Maybe you can start to figure these out and deduce which must be which in this list. I don't think you can just look at, I don't know, orange, for example, and tell what B is equal to, but maybe you can compare the value of B in this orange graph to the value of B in this blue graph and tell which one is greater. And based on their values of A, maybe you can select which is which from this list. If you can do this, great. If you can't, it's not the end of the world. This is the extra credit one. I just threw it on there for extra practice.